Let's continue to question 20. The question 20 is also known as the big boss question. It is the hardest in the whole paper. So first, we need to prove that GP equals to GR. Let's see the question. POR it equals 90 degree. G is a point on PR such that GO equals GP. So first, we need to draw a right angle triangle. Okay, so this will be O, this will be R, and this will be P. Okay, so we already know that G is the point on PR in which GO equals to GP. So, oops. So this probably here would be G. Okay, so G is here right at this point, and this two is equal. We need to prove that this one is equal as well. So how do we do that? First, we know that PG is equals to OG, so that this angle here is equals to this angle right here, because base angle isosceles triangle. GPO is equals to GOP. So let them be theta. Theta, theta. So this one will become 2 theta because of exterior angles of triangle. Also, we know that this angle right here is 90 minus theta because this is 90 degree. So we just need to find this angle right here. How do we do that? It's by angle sum of triangle. 180 degree minus 2 theta minus 90 minus theta. So the answer would be 90 minus theta. So this is 90 minus theta as well. So by side opposite equals angle, this two will be the same. So we know that GR equals to GO. And as GO equals to PG, GR will equals to GP. We continue to part B. So, a rectangular coordinate system is introduced so that coordinates of O and G are 0, 0, and -1, -2, respectively. While R lies on the y-axis, let C be the circle which passes through P, O, and R. Find the equation of C. So, if we look closely, C is actually the circumcenter of triangle POR because it passes through this 3 point. If it is tangent to this 3 point, it will be the in-center, but this is out of question for now. And also, from the above, We also know that G is actually the circumcenter of the triangle. So the remaining work will become easy. You can either use the 3-point form, which is way longer, or you can directly use the point radius. Okay, in this case, I'll use the point radius because it's way faster. So, x plus 1 square plus y plus 2 square will be equals to 0 plus 1 square plus 0 plus 2 square. And lastly, you'll get this equation, which is the equation of C. Part B2. Again, this is a very complicated question, so I suggest you to all drop down the points so you not forget which is which. So, let's start by drawing. O is 0, 0. This is R. And this is... No, this is P. Sorry. This is P. And this is R. Two tangents intersect at point S such that slope of L1 is greater than that of L2. L1 cuts the y-axis at H and K respectively. Someone claims that the area of quadrilateral SHRK is greater than that of C. Is the claim correct? So we first need to draw. S, where's S? S is there, here. 0, 5. P. G. Okay. This will be the circle. So, G is here, in the middle. It is the center of the circle. Oops. G. It is the center. Okay, let's draw two tangents. So, where's point H and K? This is point H. This is point K, probably. And also, because my drawing is too ugly, it does not necessarily cut through the circle. So point H and point K it's not in the circle. So let me draw it better. Sorry, I really can't control the eraser. And okay, draw right in the middle. Oh, why does it appear here again? Okay. Draw first circle first. And then it's still not perfect. Okay. So maybe just use a ruler. So this point up here could be, it's actually this point up here is S, which is 0, 0, 5. And the point below is R. Okay. So we begin by finding the slope of both of this line. Maybe this one is L1, this one is L2. Okay, as we all know, it intersects at 5. So both equation will be like this. This will be the first thing we know. Okay, then we need to find its slope. How do we find its slope? There's actually quite a number of ways, so I'll show you my way. Okay, as we know, this is the tangent here. This one is also the tangent. So both of it will be 90 degrees. And we also know that this, the equation here. So we can substitute. We can use substitute. Sub this one into the equation of circle, which is above. So we just copy down. And at last, we will get this equation right here. This is the equation for between the lines as well as the circle. So what we need to do now is, as we know, it is the tangent. So 14m plus 2 square minus 4m square plus 1 times 45 is actually 0. Because this one is actually b squared minus 4ac. As the tangent only have got one touching point, only implies one touching point, so delta would be equals to 0. So this is actually basically implies the delta. Okay, so after a bunch of calculations, you will find that m equals to 2 or m equals to negative 11 over 2. So L1 is y equals to 2x plus 5, and L2 is y equals to negative 11 over 2 x times 5 plus 5. So Afterwards, we can easily find the coordinates of h and k. So simply substitute y equals to 0 into both equations. Then we can get coordinates of h will be this, and k would be this. Hence, we'll know that, oh, this one will be equals to this, and this one will be equals to this. So, the work is almost done. Here, we just need to find the quadrilateral. That's all we need to do now. The area of the quadrilateral. You can see that it is actually two triangles. Just two triangles. So, it's actually quite easy to find. However, before that, we need to find the coordinates of R. How do we find the coordinates of R? It's actually you can find it by a few ways as well. The coordinates of R, of course, it's going to have here 0 on x-axis because it lies on y-axis. So we can substitute this value into this equation above, which we calculated. So at last, we'll find that coordinates of R is 0, 4. SHRK would be sum of this triangle plus the sum of this triangle right here. Great. So here 5 minus -4 because it's the height times 5/2 divided by 2 plus also 5 minus -4 times 10/11 divided by 2. At last, you'll find that, oh, the area would be 675/44, which is 15.341. How about the area of C? Actually, we have already find it in part A. Or not part A, part B1. We have find it already in part B1, where we need to find the equation. So actually, the radius would be rooting this part right here. So the radius is actually √5. So radius, note radius, area of C will be equal to pi r squared, which is 5 pi, 15.708, larger than 15.341. So area of C is bigger than area of SHRK. Very nice. The claim is correct.